In this video, we will find the domain and range of linear equations. Pictured are primary vocabulary words that you should ensure you are familiar with. If you're not, I recommend that you look in prior notes and possibly videos online. Number 8, you are making homecoming mums for an academic reward system. Each mum will have 9 silver streamers. The graph shows a linear relationship between y, the number of streamers, and x, the number of mums. You will use no more than 8 mums in the academic reward program. Which set best represents the domain and range of the function for this situation? This particular question can be answered without a calculator. However, my thought is that it would be a good idea to show you a way to use your calculator to help you out in case you don't have this lovely graph. And we know that each mum has 9 streamers. So that tells us that you would have plus 9 for each mum. And you have a maximum of eight mums total. So you'd have 0, which would be no cost, or no streamers, I'm sorry. And then 1, 2, 3. So you know that the domain is 0 to 8. Okay, and if we go up and look at the values that we need, or on our options, rather the values in our option, we see a situation where we have all real numbers and then we have a continuous situation. The first two are discrete. Well, we don't sell half a mum, and it would be bad form to sell a mum without or give away a mum without the correct number of streamers. So we aren't going to discuss partial situations. We don't sell part of a mum and we don't put half of the proper items on a mum. Okay, so this means we have a discrete situation only, meaning whole numbers. That's why we have the dots. So that tells me that D would not be an option. Now we have a restriction. A restriction first of our range. We do not, actually we have a restraint on our range because we have a restraint on our domain. Our domain is just 0 to 8 mums. No less than 8 mums, no more than 8 mums, and it would be whole mums. So we cannot have all real numbers because we have a restriction on our domain. And then when we look at B is incorrect because it doesn't take into consideration what our graph is assuming. It only gives us even numbers, and we assume the odd numbers in between. So that would eliminate option B. Now, let's verify. We know it's 1 to 8, and we know that we count by ones for our discrete domain. Now, let's check our range. How could we do this? We'll simply put it in the calculator, but you're thinking, wait a minute, I don't have anything to put in the calculator. Yes, we do. It says that we have 9 streamers on each mum. So that's 9 streamers times I don't know how many mums. So that's what our simple equation should be. There's no B value because we start here at 0. Okay, so we enter table in our calculator, clear out what is there, and just say 9x, press enter, and I'm going to say start at 0. And let's just go with our auto table, auto create, and then okay, enter. And now we have each of these y values for our range. Remember, we're finding domain and range. Well, we already know what the domain is. Let's verify our range just in case. And the reason I say this is because it's a quick way to pop in, it calculates everything. And let's say all of our values were properly discrete, but there were a bunch of different numbers. Instead of sitting there and going, okay, times 9, times 9, times 9, just go ahead and just pop it in, arrow down, make sure all of these values are verified. And the last one is 72. And that's all you need to do. Okay, it's just a good way to use this simple calculator to verify items in case they don't give you everything, in case something is missing and you need to make sure, there could be all kinds of way this question was asked. Okay. All right, now let's try another calculator. For number 8, yes, we could solve it simply by using the graph that's given to us. But the purpose here is to recreate it using the TI-84. And remember that this information, because we have dots and the situation itself, tells us that it is discrete, meaning we don't have half a mum or part of a mum, and we don't have part of the streamers. Everything is in whole numbers because that would only be proper. Okay. Now, also for our options, because it's discrete, D is not an option. That implies continuous information. All real numbers, that implies continuous information. A and B are discrete. However, B does not take into consideration the odd values that must be counted because we have the 7th mum and the 5th and the 3rd and the 1st. We can't disqualify those or just chunk them out for any reason. It's just what we see in our graph. It has just been omitted just for convenience, okay? And as you see, it just kind of makes the graph look neat and clean, okay? Although, it just all depends. It's just how it's scaled. I would have done it differently. I would have said 1 to 10 probably. And then, of course, we stop at 8 mums because we have a limit of 8 mums in this academic reward program. They're obviously giving away to students where something has been earned, okay? Would be a great academic program during the fall season, right? I could see a lot of students working hard to try to earn that over time during the school year. Okay, now that being said, okay, we need to look at our A and B options. Obviously, B has just chunked out our odd number of mums, which is not permitted. So that gets rid of that. Okay, and if you watched prior part or the other video or parts of the first video, that to be said, let's just go with what we were supposed to be doing here. We are just showing how to recreate it, and that can be done by making the equation or just creating the table. I don't want to recreate the table. That's just a waste of time. But I do know for each mum, we have a slope of 9, meaning each mum adds on 9 streamers. So that tells me my equation is y equals 9x. So I just go to y equals, I am going to clear out everything that's there and say 9x, okay, and that should give me my graph, okay? All right, so I will go second graph, and now I have the table for that graph. Okay, we could look at the graph, but it's not going to do me any good. I'd have to go zoom, and quite frankly, it's a waste of time right now. But what I do have is everything from 0 to 12. I can arrow up and down. There's my 0. Then I should have 9, 8, 18, 27, 36, 45, and it just verifies the numbers for me. And that would be from 0 to 8. Remember, we're only going to 8, which would be 72. There we go. So option A is verified once again. Okay, using the TI-Nspire, we will need to graph and then use the table so we can verify the range, each of the range items. Now, as I said before, for this particular problem, we are dealing in discrete information, which is obvious from the graph itself. It is showing discrete information. And we also know this from the fact that we do not sell part of a mum, and we are not saying it's allowed to put part of a streamer or less than 9 streamers on each mum. Now, that being said, you would look at this and say, well, I could just answer this question using the graphics. But what we're going to do is take it a step further and show you, well, you've got something where you can verify these values in this range. The domain we can verify very easily. We have 0 mums, then 1 mum, 2, 3, 4, up to 8. We have a restriction of 0 to 8, and it must be whole numbers. So we must allow 1 mum, 3, 5, and 7. Okay, so it's whole numbers. Well, that's obviously option A. So I'll scoot up a little, and again, we can see that D would be continuous information, not discrete, so D's out. C implies discrete and continuous because it's all real numbers, so that's not going to be valid. And also, it implies that you're going past 8 months, that it's limitless, and that's just not true for this situation. Now, what happens to option B? Well, option B, the domain is tossing out all the odd numbers, and that's not allowed. We need 1 and 3 and 5 and 7 mums. We're not cutting out half of the mums or saying tossing half the mums in the trash. We're giving away 8 of them in this academic reward program. Obviously, the students have done something good and they're getting their reward. So let's get rid of B. Now we're down to A. Well, quickly, we have what we need to create the equation. Well, it's starting at 0, so there's no B value. So we have y equals, and it goes up by steps of 9, and it's positive, so that's 9x. So we simply need to create a graph. So arrow down, I'm going to enter to get a graph. Well, that's a graph that I don't want to use, so I'm going to have to get a new one. Oh, here, let me go back up. I am using, let me do that again so you can see what I did. Okay, so I'm going to go to Document, and when I go up to File, okay, here I have File. It's just too quick on me here. Sorry, I need to show you what I did. Okay, now let me go to File. Okay, I want New Document, and I accidentally pushed twice because I'm on a computer. You're going to be using a handheld. And a handheld for the Nspire is a little different. You really have to get the feel of it. So I'll push enter, and then it says, do you want to save? Well, if you want to save what you had, do it. I don't want to save anything. So then I select graph. Okay, now I'm where I need to be. All I need to do is put in 9x. Just push your 9 in your x, and you have what you need because there is no b value. Okay, so push enter. Well, we get a graph. It's not as helpful as the graph that's given to us, unfortunately. Doesn't matter in this situation. We're just trying to do a little recreation. All we have to do is say menu and then go down, arrow down, and select table. Okay, and then when it's highlighted, okay, then we enter. Now it's going to give us the information we need. I can arrow up, we have 0 mums, and then arrow down. And for 1 mum, it's 9, 18, 27, and it just goes by nines instead of having to do the math. And of course, all the way to 72, which is correct, and that is option A. It just calculates everything for us so we can double check our option. Now, the reason I want to show you this is because there could be some very close options that look like they could be correct. Okay, and the numbers are just off for the range. You really need to go verify those. For us in this situation, they were really testing if you knew the difference between domain and range properly, and that you knew the difference between discrete and continuous. Okay, that's what they were really testing. But at any time, the question can be changed depending on what the purpose is. Okay, just gives you another way to verify, calculate quickly. Okay, let's try something else. Okay, using the Desmos Graphing calculator to solve this, it's going to be a little bit quicker, but you're still going to need to know the equation itself. So again, I will state that we have a discrete situation because we don't sell part of a mum and we do not put less than 9 streamers on each mum. Okay, and we know that we have a slope of 9 because we're going to go up by 9 streamers each time. Okay, each step up is 9. So this means we have y equals 9x. So putting that in my Desmos graphing, you notice we have the TEKSES version. It doesn't matter which version you use. It's going to be the same. Now, we don't want to put in the whole table. That's why I created this equation. Also, to give you a way to see how to get the equation and quickly calculate the values of the range. Now, we are going to need 0 to 8 mums. So we have for 1 mum, and 2's marked, and 3, we have 5 and 7. So we cannot have a domain that just eliminates odd numbers. We need 0 to 8 mums, okay? And that verifies the use of each dot on our graph, okay? So when we go up again, we see that D is continuous information. Therefore, we have to mark that out. And we see C is implying that it's infinite numbers, that it's every single number for the domain and range. And that's just not true. The dots themselves tell us that it has a restriction up to 8 and that it is very much discrete. Okay, meaning it's only going to be whole numbers and nothing in between and nothing after 8. So that means option B has to be marked out because it tosses out all of our whole numbers, which are rather our odd numbers, our odd values, which are counted or have, they actually are counted and have value on our graph. Okay. So that being said, we are left with A. Now that would be, of course, as I did it before, that's just a way to get it using our graph. But we have y equals 9x, so we can verify the range. Okay, so let's type that in. And that, when I put my hand on that, I have a touch screen. If you don't have a touch screen, you can use this little keyboard at the bottom. And here, let me push this up so you see more of my screen. There we go. Okay, so it'll go up and down. Look for it down here in the corner. Okay, so we need 9x, and we don't have to put in the y equals. However, that just gives us a line. We've just said that a line would be continuous, and we can't have that. We can't use that. That's not what our graph shows. So let's create what our graph shows. It isn't a big deal. So there are a couple of ways we can do this little, you could just put in the table yourself. I think that's a waste of time in this particular situation because they've given us a table. Okay, so I am, oh, here, let me go back. Let me go back. I'm going to say done. See the little gear? And it says edit list. That's what you push. Now you have the table and it'll automatically create a table for you. However, it always starts at -2. That's a default. So what I like to do is just do a type over. So I do 0, enter 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then if you want to get rid of these others, what I like to do here, I like to go down and put my cursor here, and then you can just push the back button or the delete rather, and you can just go back and delete from the back. Okay, there's a couple ways to get this done, but this is pretty efficient. So now you see everything that you need given in your table. And I have 0 and 9, 18, 27, 36, 45, 54, 63, and 72. And once again, that verifies option A. Thank you for watching. If you would like the materials that accompany these videos, you can visit us at numbersareradical.com. And once again, everyone, happy testing.